Okay, so now we're going to go over quadratics in the form of y equals ax minus r, x minus s, where r and s are the x-intercepts of your parabola. So, for example, given y equals 2, x plus 1, x minus 7, sketch the graph, label the x-axis, vertex, and axis of symmetry. Okay, so all this based on this graph right here. So I have y equal to x plus 1, x minus 7. Since this is in factored form, this tells us our x-intercepts. For any x-intercept, what is the y value? For any x-intercepts? Aryan? 0, right? So what you're essentially doing is you're subbing in 0 for x. So I'm kind of like explaining why it works and why you're doing this as well. So you're looking for the x-intercept, which means the y value is 0. What's 10 times 0? What's 10 times 0 times 100? What's 100 times 1,000 times 0? 0. So as long as any one of these terms are 0, it makes the equation true, right? So x plus 1, if you set this to 0, that means x equals negative 1. So if x is negative 1, this is true. This equation is true. So that means 1 x-intercept is at negative 1. Similarly, same thing right here. I could have x minus 7 set that equals 0. So that means x equals 7. So if x is 7, this will also make this equation true, because 7 minus 7 is 0. 0 times anything is 0. So my other x-intercept is at 7. Okay, so looking at this equation right here, my two x-intercepts are x negative 1 and x is 7. Because for those two x value, it will give me an equation to equal 0. Okay? So now that I have my two x-intercepts, I need my vertex. Okay? Well, in any parabola, what can you say a characteristic about parabolas? What's one characteristic about parabolas? Well, how do parabolas look like? Yeah. Okay, what about that curve? Okay, Aryan? It's symmetrical, right? So if these two are my x-intercept, my vertex has to be somewhere in, like either here in the middle or here in the middle. Yeah, so in other words, I have to find the middle of these two x-intercepts. I'm finding the average between these two x-intercepts. How do I find the average between two numbers? Yeah, so since there's two x-intercepts, add them together, divided by 2. So negative 1 plus 7 is 6. 6 divided by 2 is 3. So I know that my axis of symmetry is somewhere right here when x is 3. Okay. X equals 3. That's my axis of symmetry. So I know my parabola is either going to go this way like this or this way like this, with that being the middle. All right. Well, remember how when we did the chart, we said axis of symmetry x value is always equal to the x value of your vertex. So your vertex is going to be 3 and something. All right. What is that? Where exactly would that be? Well, you are given an equation. You are given an equation in y equals form. I know what x is now, so let's just sub it in to figure out what y equals. So, yeah. So when x is 3, you can figure out what y is. So 2 times 4 times -4. And if you did your math correctly, these two numbers should match up because it's symmetrical. So 2 times 4 times -4, you get -32. -32. So your vertex, 3 and -32. And that's why I had the graph set up like this. About right here. Okay. And there you go. Sketch the graph, label the axis of symmetry, vertex, and axis of symmetry. So I have my 3 points. I can make my sketch like this. That one not so nice, but this one looks nicer. Kelly makes me feel so proud of myself knowing how to draw lines, graphs, curves.
Will we ever need to convert a parabola into factor form?
Uh-oh.
It's not just reading off of it.
Because that's last chapter,
That's last chapter.
which carries on to this chapter. Yes. Okay, so there you go. So we just graphed a parabola based on factor form. All right. So right here, I don't like this graph. It doesn't look so accurate because I only have 3 points. What's one easy way to figure out one more point on here? Yeah, Max? I heard somebody say it here.
I was telling her what like spend into the quadratics a lot.
Oh, sorry. Okay, so I have the x-intercepts. I have the vertex. What's one more point that might be very good to have? Yep. The y-intercept. What's the x value for y-intercept? X is 0. So use the equation. When x is 0, 0 and 0 are here, you have 2 times 1 is 2. 2 times -7, -14. Oh, it is pretty good. Wow. Yeah, right there. Okay. And how many points usually do I ask for on a test? 5. Can I plot down another point on here?
Yeah, just plug in a number.
Okay, or yeah. Yeah, remember it's symmetrical. So if I know that this is 0 and -14, that means on this side it's going to be 6 and -14, which is right here. A little off, but it's okay.
So we're not gonna have anywhere like the x-intercept will also be like the line somewhere like one point will be on the origin. Is it not gonna be like that?
It's not necessarily the origin because like we did the introduction on the y equals x squared graph where the vertex is at the origin. But then after that first day, notice all the graphs are not at the origin anymore.
You asked for 5 points, right?
Mhm.
It's the y-intercept and the x-intercept.
Oh, on the test, I'll specify which points I want. Yeah. Normally, it's definitely the vertex, x-intercepts, y-intercept, and one other point. Yeah. Because those are the most important points on the graph. Okay. But if I don't specify, you could do the step method. Then the step method, then you just have to do the vertex and then any 4 other points. Okay. So on the test, I'll specify which points in particular I want. Okay. So one last example. Given the path of a soccer ball is shown. Okay. Find the equation to model the path of the ball. What is the maximum height it reaches? Okay. So that's all the information I gave you. A graph like this. So let's try to come up with the standard equation. So remember, in the standard equation for factor form, x minus r, x minus s. Okay, that's the general equation of a factored form. So what's r and what's s in this graph? Yep. 0 and 8. My two x-intercepts are 0 and 8. 0 because obviously that ball starts off on the ground and then you kick it, you lop it. And so those are my two x-intercepts. So to sub it in, I have y equal a times x minus 0, x minus 8. Oh, question.
So are R and S always the x-intercept?
Yeah. No, sorry. We have so many different letters. Like just H and K represents the vertex, R and S is the x-intercepts. Yeah. It's okay, guys. There's no bad questions. Just to be clear. Okay. What's x minus 0 though? X minus 0? What's x minus 0? Yeah. X. Yeah, so I can simplify this equation to just y equals a x minus 8. Yeah, I don't even need the bracket. I could just have it like this. All right. So just like yesterday's lesson in vertex form, how do we find out what A is? Just like yesterday. Yep. Okay. So, but based on yesterday's lesson, what did we have to do to figure out what A was? I plug in the x and the y. What point can I use? 5, 1. So notice in the whole graph, I only gave you 1 point right here, which is not 5, 1, 1, 5, right? Okay, so I can plug in this point for my x and y. So sub the point 1, 5 in for x and y. Okay. Notice yesterday, we used the vertex to set up our equation, and then we had to pick one other point. This time, we used our x-intercept to set up the equation, and we had to pick one other point. If I was given the vertex, I could use the vertex then. Right, so if you're using the vertex to set up your equation, then you can't use the vertex. You can use your x-intercepts. If you're using your x-intercept to set up your equation, then you can use the vertex. Okay, so subbing it in, 5 equal A, and then 1, 1. I subbed in the 1, 5 in for x and y. So 5 equal A times 1 times -7. So I'll write it all out. So you get -7a. So a is -5/7. Okay. Does it make sense that my a is negative? Because my graph is opening down. All right. So remember, it should match up. Opening down, -a. Opening up, +a. Okay, so what's the equation of this parabola then? now that I have A and I have this form? Y equal?
5% times x times x.
Perfect. Good. Okay, so this is still an equation of a parabola, just in factored form. Okay. So this is my equation of this parabola. Part B, what is the maximum height it reaches? So this was part A. Part B, how do I figure out the max height it reaches? Aryan, what's your idea?
It would be the vertex, so you just find the average of the both x-intercepts, which would be 4, and then you plug that into the equation.
Perfect. So remember your maximum height. That's why, based on the first lesson, I said I want us to be familiarize ourselves with the words maximum and minimum. So we know that whenever it asks for maximum height, we are looking for the vertex. So this point right here, which is in the middle of these two x-intercepts, it will be at 4. So sub in when x is 4 in this equation. -5/7. So 4 and 4. Okay. So solving it, we got y equals -5/7 times 4 times -4, which gives you 20 times 5. Yeah. Y equals not negative, 80/7. Whoops. Okay. Notice that yeah. So I made this silly mistake. I put a y equals negative, but then wait a second. My vertex based on this graph has to be a positive number. So then I was like, oh yeah, 2 negative. Right? So remember again that your answer here has to make sense. So my therefore statement, therefore, I didn't put units. So let's just say like seconds and meters. Okay, let's just say. So we'll say, therefore, the ball reached 80/7. What's 80/7? 11.4. 11.4 meter in 4 seconds. Okay. Or better yet, the ball reached a maximum height of 11.4 meters in 4 seconds. Okay. Okay, so there you go. This is all of chapter 5. We just finished chapter 5. Yeah. Okay. Yeah. Okay. We actually did a lot, actually.
The test is gonna be tomorrow.
Friday. Yeah. So we actually did a lot in this chapter, but I think you guys did really good. So we learned about the different transformations: up, down, left, right, stretch, compress, reflect on the x-axis. We learned yesterday how to, given a graph, come up with the equation in vertex form. And today, given a graph, how to come up with the equation in vector form. Okay. If remember, I could ask you guys to change this to standard form as well. So just to change this from vector form to standard form is just multiply, and you have your standard equation. Okay, distribution. So for the rest of the class today, please work on these questions. Okay, in about 5 to 10 minutes, they'll call us down for the assembly. We are sitting in rows 7 to 9 on the right side. Once we come back, just continue working on these. Anything not done will be homework. Where do you find the homework? Right space, content. Whoop. Right space, content, chapter 5. And then right here, the homework. This homework file. Okay, remember chapter 4 homework. This file is 16 pages. Okay, if you scroll down, so on your let me go back to this. So page 192, 3D, 4AB, 5, 7, and 8.